after finalizing the design of the landing gear for the JRM1, it was time to print the first prototypes. First closer look to the strut parts. This one is lightweight PLA printed, 2 walls, 9% gyroide. Here we got PLA carbon fiber reinforced, printed by the Bambu lab. Also 2 walls and 9% infill. And we got 2 parts from the upper strut, just in lightweight PLA. The wheel hubs are printed also from lightweight PLA and the tires from VarioShore TPU. And now it's time to bring everything together. These are the hubs for some ball bearings. This is the complete printed wheel with 20% gyroide made from VarioShore TPU from Color, and this will bonded with super glue. These construction from lightweight printed strut parts reinforced with carbon fiber rods was well approved, but it was very work intensive, so the idea was to print the whole landing gear complete in carbon fiber reinforced PLA. Here we can see the first parts printed. The wheel brake and also the lower strut. I was using the default settings on the Bambu Lab slicer. So here we have a closer view to examine the surface, and this is really nice. I just raised up a bit the flow to a bit over 1. The walls look nice. Here we see the bridging wall. This is not structure from the part. This I will sand a little bit. It's okay. I'm not so happy with this gap here in between. This looks not so good also here. But let's see, I will sand a bit. Here I started already sanding. Then it looks much better. And then we want to paint it. This was my very first print with carbon fiber reinforced filaments. So I was happy in the first moment. But afterwards you see there is a lot of work to do. And the goal was to get an already perfect strut out of the printer, and at this moment we are far away from this. The good thing on this black color is that you have a nice contrast after sanding the walls down. The structural integrity of such a part is absolutely important, so I used gray color to make failures in the layer and the whole print better visible. Especially the first layer above the support looks absolutely not nice and needs a lot of improvement. The walls and also the upper layer were okay so far. While the paint is curing on these first test prints, I was figuring out how to get a much better surface on the first layer, especially in the gap between the support and the part itself, to figuring out if this first layer problem is caused by this carbon fiber reinforcement. I printed some second parts with normal PLA. Here are some print results of the lower strut, and we see there are some issues. This is printed by Tough PLA from Bambu Lab. This was the lower side. It was printed like this, and there, especially on the surface where the support ends, it's not good. Even here something break out, and I don't like the surface above the support. I was working on the interface spacing to bring it below 0.2, but nevertheless it's still bad. This is the upper side. This is much better, but on the lower side we can see the same issues. Also something broken out, and you can see spaces between the layers. So I try something new, and this is using the support PLA from Bambu Lab, and this looks like this. It's the same part, the lower leg from the same material, and the white areas is the support PLA which is printed, so we can go to 0 support set distance. And I also did some adjustments to this prime tower. I did it small as possible. This you can do on others. You see, I did it much smaller than it is already, but even if you put smaller numbers in here, it will look like this, but it's the half size of the default one. And I moved it much closer to the part so that the nozzle don't have to move so much weight. I let's see how this works with zero space. And the specialty on the support PLA is that it doesn't bond to the normal PLA. It's something like grease or like release wax, I think, compared with the composite techniques. And let's see how it looks in the printer. And the reason why I put it this time this way and not again this way is because of the low numbers of levels where he has to change the filament. You see, this is not even, this is angled, and so many times he need to change, and this take time, and he has to purge a lot of materials when I would print this way. And this way we got just have the bottom, then there is a little bit lower this, so much lower number of different levels. And when we take a look here, you see the white is just on about 4 levels, so not so often. And here the Bambu lab is printing, and you see a lot of time is running out just for purging and changing the filaments. Also, there's a big temperature difference between the two materials. The normal PLA is printed with 220 and the support PLA with 240. So he has to cool down or heat up, and this takes a lot of time. So for next, I will change the basic filament that fits much better to the temperature from the support, or that these both filament fit in its print temperature. You see now it's on 240 again. There you lose a lot of time spooling back and forth of the two filaments, more than 2 times of the normal print. So it's heating up again for the white material. And there is the part with the support PLA. Took about 3 hours. Looks really good from the first view. Yeah, that's a nice quality. Okay, let's move the support. Caused by this special pattern here. It's super easy to remove the support. Just pull on one side and you can get it out. This is very nice. So, and now the interesting part. And yeah, this becomes loose, and look at this surface. It's even the same like on the very last layer. I just can pull this off with my fingers. Is this cool? This is so cool. Look at this. Just like a release film, like wax on the composites. Also here where it is a bit lower, you see it just jumps out. So, and this hole is finally super round and not this deformation like on the other times. Perfect. Use this little metal tool. This is sharp and round. For this I can grab under it and easily push it up without destroying anything. This feels a bit like nylon, this special PLA. You can push with a lot of power on it. This is just amazing. Nevertheless, some layers became loose here in this round area. They can loose. And here we see when the support has to go upwards. This looks like this originally. So here was very little support used. And we will try while designing parts that we just have flat surfaces, because for every little layer of this, they have to be a change from the materials. This takes a lot of time, a lot of purchase. Also this super easy to remove. Just grab under it. There it is. Oh, but then this happens. Yeah, this was just the beginning. Oh my god. Yeah. That's not good. That's not good. The adhesive of the fibers itself. This is very cracky. I don't know why. If the setup from the Bambu lab material is not correct, or why this happens. But you see, they super easy depart. There's not a good adhesive between the layers. This is the rough PLA from Bambu lab. Oh. That's not good. That's not good. So the outside quality was nice, but the stability, not so good. Okay, let's figure out why this happened. Yes, I can break it easily apart. This is the normal printed part with same material for support. And when I try here, you see here I can press, and also here press, and it's bending, but it's not breaking. And this is the basic PLA from Bambu Lab. Also the same. Yeah, you can press, pull, and this stays. This is how it should work like. That's not good. See here, this is breaking, and when I press here with power, yeah, I can press with much power, but no cracking sound. Okay. This is just a half success or a little success, because this works, but yeah. So let's figure out why this could happen. Here with the Bambu Lab PLA Tough, automatically selected, and Bambu Lab support. Yeah, and this is printed at 220 degree, and the support material. So at the moment I don't know why this happened, why this part becomes so weak. Just could be because of these often made changes between the two materials, but also in areas in here it was very fragile and break, and there was no change in between. So yeah, I don't know why this is much more rigid and stable and solid. If you got an idea what could be the reason that this is so fragile, write it down in the comments. Let me know your ideas. Next try is to print the same part with the PLA carbon fiber reinforced, and also with the support PLA in between. This time the materials have more the same print temperature, 230 at the carbon PLA and 220 at the support PLA. Next part is ready. PLA carbon with this support PLA. Let's take a look. It's clean printed. This looks nice all over. Hopefully the strength is this time better. So here we got a new part. Looks nice and clean. Let's see how easy it is to remove. It's like a mundharmonica. Here I'm using again a special tool. This is more bonding on the surface, but at the end also is possible to remove. No big deal. I was just removing the infill from these holes and suddenly it break apart. So the same problem, oh no, the same problem we just had before with the red version. Yes, the quality is superb, but the stability is worse. Here we got the same part, just printed with the carbon PLA and then painted gray. And you see, nothing happens, it stays. And this just, everything breaks apart. Here I can press, this stays, and this, Why? It's exactly the same number of walls, upper and lower. Just the direction of print, this lays this way, this was this way printed, and this one stays like this. This was the only difference. Maybe this is an important difference, but nevertheless this is much more rigid. Can't think that this is the reason. Yeah, so just could be that, what could it be? What could this be? So this gear part will be tested, and this has to be continued. The only problem with this one material mix is that the surface quality is not that good. You see there are, especially this, where you don't have this zero set distance on the support. This is not the best surface, but these parts stay. They are rigid, they are stable, they hold, they are not falling apart, and this is more important. Yeah, and we got this problem on this carbon, all these gray painted parts, you know, these are all the carbon parts, and the same was on the PLA. So the problem seems not to be caused by the material itself. It seems to be caused by the way of printing, with stopping in between with this other material. Yeah. Let me know your thoughts about this topic. Hopefully we can solve it to get the best results from both of them. While the carbon axles has also been printed, and I'm looking for a nice way to paint this head, and one way is with this pen. Now they are orange, and another way I will test is just put it in this emile color from Revel. Let's see. Yeah, and this looks red. Okay, let it dry and see. And then it was time for the first assembly. Here the two wheel shells are bonded with super glue. I was using just a bit accelerator, then press it with full power together, and if needed add some super glue on the outside. The ready printed 4mm carbon axle go into the lower strut and were saved with 2 screws. This makes the whole construction super rigid and stiff. Now the holes for the 1.6mm ball heads were drilled, and the brake is installed and hinged with a 3mm printed carbon bolt. The main parts are ready assembled. We got the lower gear leg, the brake, and the upper strut part. Here we can see the heads of the bolts in a nice orange color. All are saved. The lower one with 2 screws, this one for the brake 1 screw, and also 1 screw in here. And now it's time for the servo. And finally the servo can be attached, and the wire is fitted to the carbon clips. Servo is installed. Also the wire is in these 2 clamps. They are already printed on, and so it can move easily without any damage of the wire. Now it is time for the rubber bands. These realize the suspension of the gear. On each side is enough space for installing 2 of them. This is the ready assembled gear. Let's take a look at the weight. About 66 grams. That's super lightweight. Such a big landing gear, including brake and brake servo. The carbon fiber reinforced PLA gear is now mounted on a stress test, and we can see how nice this tire is working. Looks super scale. Yeah, it's really soft printed. And we got 1.5 kilogram load on it. This is designed, this gear, for about a 3.5 kilogram airplane. So this is the original main gear load. And let's take a look what happened. Oh, the wheel is getting warm, and you see it's getting flat. It's interesting. Temperature on this 3D printed wheel makes it a bit more soft. Let's see what it looks like. Okay, stays this way, so this shouldn't go too hot. Yeah, the infill into the wheel is destroyed, so it stays flat as if the air is out of the wheel. So I can't use this anymore. I will change to another wheel, but rest looks good for the first moment. So this was easy done, just removing the 2 screws, and here we got the wheel. Well, this feels soft and is like a spring. This is hard, so I will do a cut. So from the first moment, I can't see directly a damage. The gyroid looks still good, but something changed here. You see it's still flat. So I will use some more gyroid, or even do not the testing with this high temperature, because normally when you do a ground run, it's not getting that hot. A new reel is installed, this time with old ball bearings, so the bushes goes direct on the carbon axle. So let's see if this stays. So this looks good. I think this will also getting warm, so I don't want to melt the carbon axle. This should stay for the test. Okay, this test runs good. Next is the drop test. It's mounted a bit more forward and it will drop from about 15 centimeter. Yeah, this looks good. So now the same with 1 kilo more mounted. And it goes to maximum. The servo touches, but it stays. Nothing breaks. That's good. So let's take a detailed look. You can see here that the pin is bended. It's a lot bended. So the printed part stays, but the metal was not strong enough. Next time I will use some feather steel. And the lower axle looks quite good. This is where the wheel was running with the brass bushes. Looks nice. Here's a bit material removed, but I will normally use this with ball bearings, so there is no force and no rotation on this axle directly, so there's no problem. But it doesn't break. This was the important thing. This is just printed. It stays, and the rest also looks nice, so I will remove this pin. And here we got the pin. It's a lot banded. Here we can see the latest gear version in a preview. And when we take a look inside, we can see the 50% gyroid and 2 outer walls, 3 bottom layers, because the first bottom layer is not the best quality, so I added one that I'm sure that 2 layers are perfect as well. And as you can see here, these tubes, they are inbuilt. They are printed inbuilt. They are just hollow tubes, and they act like carbon tubes. This works really nice. And another important thing is when we take a look to the direction of the layers, we can see they are 45 degree. The same here. This 45, then the other direction 45, plus minus 45, also mixed with 0-90 degree. And that's super important. This is like when you build up in composites. There you also have different orientation of the fibers for different loads. Bending, torsion, and so on. And especially we got a lot of bending. So we need these layers along the longest part length. And we are also prepared for torsion with these 45 degrees here. For this I used these patterns, monotonic line, just monotonic line and gyroid infill to get this. Otherwise you would have not these clean lines. And here we can see the Bambu printing with 150 mm per second print speed. This is still very fast, as you can see. I love this colored PLA carbon fiber. It's looks much better than the black one. Quality looks really good. Okay, let him print. And here it is. Wonderful looking. Oh yes, this is much more beautiful than the whole black color. I love this painted PLA carbon fiber. Still a bit warm. Let's take a look at the support settings. When we go to normal support expansion on 0, we see there is a lot of support also outside of the part. Now it is set to minus 0.3, and we see there's just in some areas still too much support on the outside, especially here where it's not that easy to remove, where the screws come in, also there for the pin. Let's see what happened when we go higher with this value. Now it is on 0.6, and you see all the support outside of the part is gone, so this will be nearly finished after removing it from the print plate. Let's take a look what happened when we work on the threshold angle. Normally this is something that interacts with this here, so when the angle goes lower, the support should go more into the radius. Let's see what happened. I put it to 10 now, but there is no difference. Let's see what happened when I go to 100%, 100 degree. I mean 90. 90 is is the maximum. More than 90 is not possible. Let's see. And it's absolutely the same, so there seems to be no influence of the support. The only thing where you can adjust something is here with the expansion. Yeah, that's interesting on this slicer. After some testings, I put it to minus 0.5. So there is minimum support, but especially here on this cable holder, there is still support. When you go higher to 0.6, this would be also missing. And you see the blue areas, this overhang walls. So this could be critical. So it's always a compromise between too less and too much support. But I think this should work better, because normally the threshold angle should influence how long the support goes up here. This looks not so good in the part. If you take a look at here, this could be better when the support goes more up into the radius. Yeah, but this is I can't influence this with the threshold angle. This is yeah, not so nice. And these are the next parts from the gear. This is the braking lever and also the axles and some washers. And this time I'm doing 3 walls, 3 upper and lower layers, so a bit more rigid, especially because of the axles. The axles are flattened on its bottom for better adhesion to the print bed. Yeah, let's see how it looks like, and everything will print it in other color, this time green. And the next parts in green are getting printed. Looks wonderful. Adhesion is again perfect, even with the small area of the parts. Everything looks really nice. Super cool. And the next parts are ready. They look just wonderful. I love this green. The adhesion on the print blade is again perfect, even with this very small surface. You can take a look at the first parts and also on the final results we got there. The first, you see, especially in here, this is not so nice. This first layer, not that correct, but it's getting better. Here it's already much better. Just some little holes in there. These two ones are painted. Originally they were also black. This is a black one, but not printed in the correct position. This was printed this way, and here we can see the pin, the cable holder is broken, because we need these different direction while printing, not just one direction. And here we can see the final results. This is from the painted carbon fiber reinforced PLA. This is absolutely perfect. I'm super happy with this result here. Green and blue. This is the lower side, and we can see there also it's a little bit uneven, but much better. And what I did was I went on Z distance from 0.2, which was default set in the Bambu slicer, to now 0.12. And I think there is still possible to go closer, maybe to 0.1. Still easy to remove the support, and the surface is getting better and better. Here we got both parts. Here was set distance on the gray one 0.2 and on the blue one 0.12. and this makes it better. Also the print speed was reduced to 150 millimeter per second. Here you can see again the black one was printed with set 0.14, I think, so a bit more distance, and the blue less, so the blue quality is again better. Also the green looks so perfect. Cool thing on these colored carbon fiber reinforced PLAs, you don't have to paint it afterwards, and this was the goal, to have minimum work, just print and assemble, and I think I'm on a good way now. Just some problems with the wheel, but I think they will be also solved. Yes, Mark and I went through a long journey from the first design stage to the improved ones, while adding a brake and adding these detachable axles over the first print, then improving the print quality, but at the end we are super happy. We got what we want. Nice looking, super lightweight landing gear with a very big suspension, and everything is detachable and removable, and we are looking forward to install this wonderful landing gear to our JRM1. So if you like these videos and you want to support the channel, you will find some links underneath in the video description. You can become my Patreon or donate on PayPal. And if there are some questions left, let's write it in the comments. And I will see you in the next video. Bye bye.